Okay, so I'm going to show you how to multiply a binomial times a binomial. It's very similar to what we were doing yesterday when we were distributing, except now we're actually distributing two pieces. So both this x and this positive 2 need to be distributed to the x and the positive 4. So a little bit different look, but we're going to start with x, distribute it. Then go back to 2, distribute it, and then we'll simplify after that. So this is what that's going to look like. We're going to do x times x. So x times x is x squared. Then x times 4 is positive 4x. So we distributed x to both pieces. Now we need to distribute 2 to both pieces. So I usually write that under here. So 2 times x is going to be plus 2x. And 2 times 4 would be plus 8. At this point now, we just combine like terms exactly like we were doing on our distribution notes. So we have plus 4x and plus 2x. I don't have any other x squareds. I don't have any other constants. So these are my only like terms that I can combine. So we're going to have our final answer, x squared. 4x plus 2x is plus 6x, and then plus 8 on the end. So we multiplied a binomial times another binomial, and we ended up with a trinomial. Okay, so next example, we have y plus 5 times y plus 1. So again, we're double distributing. So we start with the y, distribute it to both pieces, then go back to the 5, distribute it to both pieces. So starting with the y times y is y squared. Y times 1 is plus 1y, or you could just put plus y. You don't really need the 1. So we distributed y to both pieces. Now we distribute the 5 to both pieces. So 5 times y is plus 5y, and 5 times 1 is plus 5. So we distribute both of these pieces to both of these pieces. At this point, now we combine like terms. So I have my like terms, 1y plus 5y. Don't have any other y squareds. I don't have any other constants. So I'm just going to add 1y plus 5y, which is going to give me 6y. So y squared plus 6y plus 5. Okay, so a couple of things that I've done here that you definitely need to recognize. Y times y is y squared, right? When we multiply these together, the product rule says we are actually adding a y. I put another y with it. I get y squared. When we are adding here, we can only combine like terms, and when we add, we only add the coefficients. So 1 plus 5 gives me 6. I keep the y. So addition or subtraction, if it was subtracting, we keep the variable exactly as it is. When we multiply, we are adding those. So we've learned that already, but just want to remind you of that there. So. Okay, this one's a little bit different because this is a minus or a negative term, so it's going to look just a tiny bit different. Really important that you get the signs correct, otherwise you'll get the wrong answer every time. So we have a plus 5. We're going to distribute both of those to a minus 2. So we start with a times a would give us a squared. A times negative 2 would be negative 2a. Then we move to the 5, so 5 times a is plus 5a. 5 times negative 2 is minus 10. Just like all the other times, we combine like terms. Now I have a squared. I don't have any other a squares. I just have a and a. So we can combine negative 2a and positive 5a. So our final answer will be a squared plus 3a minus 10. All right, m plus 3 times m minus 3 times m plus 6. So m times m is m squared. M times 6 plus 6m. Negative 3 times m is negative 3m. And negative 3 times positive 6 is negative 18. Combine your like terms, so 6m minus 3m. M squared, 6 minus 3 is going to be positive 3m minus 18. So m squared plus 3m minus 18. Okay, next example. Now we have a coefficient on this x, so we're still multiplying here. All of these that before were just 1 times 1, so there's a 1 and a 1, and then same thing here, m had a 1 and a 1. Now we just have a coefficient in the front, so we're actually multiplying that as well. We were multiplying before, but 1 times 1 is just 1, so we can kind of just leave it like that. Now we actually have to multiply. So 2x times x is going to be 2x squared, right? Because 2 times 1 is 2. Then 2x times negative 4. So 2 times negative 4 is negative 8x. Then we multiply by 1. Multiplying by 1 doesn't change anything. So 1 times 1x is still plus 1x. 1 times negative 4 is still minus 4. From here, we combine like terms. You should recognize our like terms are always ending up in the middle. If you distribute in the order from left to right, it should always end up like that. So negative 8x plus 1x is going to be negative 7x, and then minus 4. Okay. So the next one, now our coefficient is on the second set of parentheses. No, nothing different here. Now we're just going to do x times 5x instead of 5x times x. Actually, those are the same thing. Multiplication is commutative. It doesn't matter which order you do it in. So x times 5x is going to be 5x squared. X times negative 4 is negative 4x. Then we distribute a negative 2, so you have to take the sign with it. So negative 2 times 5x is going to be negative 10x. And negative 2 times negative 4 is positive 8. Combine like terms, again, are in the middle. So 5x squared minus 14x, negative 4 minus 10 more is negative 14, then plus 8. All right. So now we have coefficients on both of these. So now we're just multiplying this one times this one. So 6a times 2a is going to be 12a squared. 6a times positive 3 is going to be plus 18a. 2 times 2a is plus 4a. And 2 times 3 is plus 6. Combine your like terms. They should be in the middle. 18 plus 4 is 22. So 12a squared plus 22a plus 6. All right, and then we have 4x plus y times 7x minus 2y. So the difference here is now we have a variable here and here, and here, and here. So you're still just distributing, but now you're distributing variables each time. So 4x times 7x is going to be 28x squared. 4x times negative 2y, so we do 4 times negative 2 would be negative 8. And x times y is just xy. I don't have any x's over here, so I just put that one. I don't have any other y's over here, so I just put that one also. So we put both of them x, y. Then we do y times 7x. So y times 7x, very similar. So that's like 7 times 1 would be plus 7. I don't have any other y's. I don't have any other x's, so I just put those together, and we want to put them in alphabetical order. So we don't want 7yx, we want 7xy. So I know it seems a little bit backwards from the way it's written, but we want it in alphabetical order. Then y times negative 2y would be negative 2y squared. Y times y. We had one here, added another one here. At this point now we combine like terms. They should be in the middle, and they in fact are. So we have 28x squared. Negative 8xy plus 7xy is going to be negative 1xy, and then minus 2y squared. We cannot put these together, the x squared and the y squared, because one's x and one's y. We put xy in front of the y squared term because we put them in alphabetical order first. Okay. So on the next page, now we have a couple of special case ones that we want to start recognizing patterns for, because these are on your reference chart for the EOC. So really important that you know what those special patterns are, so we can actually make that formula chart or reference chart valuable. So you should notice that we have y and 6 and y and 6, one's minus, one's plus. So essentially, same exact thing except they're opposites. This is a -6 and this is a +6. So opposites typically will cancel out when we're adding or subtracting. So let's keep that in mind when we get our answer and see what happens. So we start with y times y is y squared. Then y times 6 is plus 6y. -6 times y is minus 6y. And -6 times 6 is minus 36. From here, we combine our like terms, which should be in the middle. So we did, in fact, get positive 6y and negative 6y. So 6 minus 6 is a zero pair. These are going to cancel out. So we get y squared minus 36 as our final answer. So this is actually called a difference of two squares. I'm going to write that out here. So difference of two squares. Sometimes they just leave 2 out and it's just difference of squares. And what that means is I have the difference, so I'm subtracting, of two perfect squares. So I can take the square root of y squared, I can take the square root of 36, and each time it's going to follow the same pattern. So I know if I have the same thing, just opposites, I really only need the first term and the last term because these two middle terms will cancel out. So using that pattern, you can still multiply every piece if you want to. If it's confusing to you to follow the pattern, completely understandable that you would still multiply. But really important for some of you that you start recognizing that. So again, I have 3x plus 1, 3x minus 1. Same exact thing, except one's positive, one's negative. I know that the middle two pieces are going to cancel out. So I only need the first term, which I get from 3x times 3x. So that's going to be 9x squared. Then the middle two pieces cancel out, so then I can just go to the last term. So 1 times -1 is going to be minus 1. So again, I have the difference, so subtract, of two perfect squares. I can take the square root of 9x squared, and I can take the square root of 1. So difference of two perfect squares. The next one, same pattern, x plus y, x minus y. So I know the two middle pieces are going to cancel out because they're opposites. So all I need to do is x times x is x squared. Middle pieces cancel out. The last piece would be y times -y, which is -y squared. Again, difference of two squares. And the last one like that, 2r plus s and 2r minus s. So exact same thing, except one's plus, one's minus. So middle pieces cancel out. So I need the first piece, 2r plus 2r is 4r squared. And I need the last piece, s times -s is -s squared. So again, difference of two squares. So perfect square, perfect square. Okay, so now I have another 4 problems that are a little bit different. So we have x plus 4 squared. The most common mistake that students make here is they try and just say, oh, I do x squared and then 4 squared to get 16, so my answer is x squared plus 16. But what's really important is you remember that squaring something means to multiply it by itself. So if I'm squaring x plus 4, that means I'm multiplying x plus 4 times another x plus 4. And when I do that, I'm not going to get x squared plus 16. So let's see what happens. X plus 4 times x plus 4. So we do x times x is x squared. X times 4 is plus 4x. Then 4 times x is also plus 4x. And 4 times 4 is plus 16. So this time, these are not opposites, right? We had the same exact sign, exact same thing. We ended up with plus 4x and plus 4x. So when I combine those, I get x squared plus 8x plus 16. So this pattern is a little bit trickier for some students. So I could just square x and square 4 to get the first term and the last term. But I know because I have the same thing that I'm going to get the same thing here, and then I add them together, and now I have double that. So this is how I kind of explain the pattern to most students. I would take The first term, I do x squared. That's how I get the first term. The last term, I take the 4 and we square it. That's how we get that. The middle piece, we multiply these two times each other. So x times 4 is 4x. Then we double it because I'm going to get that twice. I'm going to get 4x and 4x. So I double it. And when I double 4x, I get 8x. So I multiply these to get 4x. Then I double. So essentially multiply by 2, but I really want you to understand how I'm getting that. So not just times 2, but why? Because I get it twice. I double it. So plus 8x. So that is how we get this middle piece. I'm going to just draw an arrow in a different color. So that's how I get that piece right there. Okay. All right, so let's look at another example and see if we can use that pattern then. So we have 2m minus 5 times 2m minus 5. So I could write it out, 2m minus 5 times 2m minus 5. So I see I have the exact same thing both times. So I know that this is one of the special ones. So the trick, not trick I guess, but the pattern that it follows is I take the first term, 2m, and I square it. So 2m squared. So 2 squared is 4, m squared is squared. That's actually m to the 1 squared. So that's going to be 4m squared. Then I take the last term and square it. 5 squared is going to, actually that's a negative 5 squared, right? So negative 5 squared, negative 5 times negative 5 is positive 25. Okay, and then the middle term, that's where it gets a little bit sketchy here. So we multiply these two by each other. So 2m times negative 5 is negative 10m. So we multiply those two, then we double it. So negative 10m doubled is going to be negative 20m. Because we would get negative 10m and negative 10m when we multiply 2m times negative 5 and negative 5 times 2m. Those are going to be our middle pieces. So adding those together, then we get negative 20m. Okay. So this one, 6x plus 2 times another 6x plus 2. So 6x plus 2 times 6x plus 2. So to get the first term, we take the first term, 6x, and we square it. 6x squared is 36x squared. To get the last term, we take the last term and we square it. 2 squared is positive 4. To get the middle piece, we multiply these pieces together, so 6x times 2 give us 12x, and then we double it. So when I double 12x, I get plus 24x. And the last one there, a minus 3b squared, so a minus 3b times a minus 3b. Same process. I see I have the exact same thing. So I know that this is a special one that can follow that pattern every time. So I'm going to take the first term, a, and square it, which is a squared. Take the last term, so negative 3b, and square it. So that gives us positive 9b squared. And then to get the middle piece, again, we multiply these, and then we double it. So a times negative 3b is negative 3ab. We double that, we get negative 6ab. So these are called perfect square trinomials, these four. So the top four were difference of two squares. These are called perfect square trinomials. So I'm going to write that out to the side. So perfect square trinomials. Okay, so let's look then at the last side of this. We have a binomial times a trinomial. Nothing changes except I have one extra piece here. So I'm still going to multiply x times every one of these. So now I'm multiplying by x 3 times and then by 4 3 times as well. The way you line it up can really make a difference in just how it looks to you. So I'm going to show you a couple of different ways. So we have x times x is x squared. X times 3x is, sorry, that's actually x cubed. Let me go back. So x times x squared is x cubed. X times 3x is plus 3x squared. And x times negative 6 is minus 6x. So we distributed x to all three pieces. Now we distribute 4 to all three pieces. So 4 times x squared is plus 4x squared. So notice where I put that. I lined it up with my other x squared term. I know I'm going to have to combine like terms. And so if I go ahead and line them up, then that works out vertically. I could write it out all horizontally and then combine like terms from there. I just think this is a more visual way to see, like, oh, these are x squareds, these are x squareds, they're going to go together. Then 4 times 3x is going to be plus 12x. So again, I had my x term here, then I have an x term here. And then 4 times negative 6 is minus 24. So I can see I don't have any other x cubes and I don't have any other constants. So both of those are just going to come down. So that's going to give me x cubed plus 7x squared. 3 plus 4 is 7. Negative 6 plus 12 is plus 6x minus 24. So this time we multiplied a binomial times a trinomial. We got 4 pieces, which we just call a polynomial. Okay, so then we have 3m times 5m squared. That's going to be 15m cubed. 3m times 6m plus 18m squared. 3m times negative 4 minus 12m. Then 2 times 5m squared is going to be plus 10m squared. So again, notice I lined it up under the other m squared term. 2 times 6m is plus 12m. And 2 times negative 4 is minus 8. Now I combine like terms, and since I line them up, it's a lot easier to see. So 15m cubed, 18m squared plus 10m squared is going to be positive 28m squared. Negative 12m plus 12m, these are opposites, so these are a zero pair. I'm going to cancel out basically. And then negative 8 or minus 8. So this time our binomial times a trinomial resulted in another trinomial, but we're missing our m term because it gave us 0. So the only time that happens is when something essentially gives you 0. Okay, so I hope that that helps with double distribution. Let me know if you have any questions. Come in during WIN and get some help if you need to.